Hey guys, so this is your trainer Anirudh Chhillar. So we are back with one more video of OSPF. I hope you are learning in a good way and a good pace. So let's go for the next video.
Let's talk about areas in OSPF. So in OSPF, we can use areas as well, as you know very well from CCNA and CCNP itself. And one area, like if someone asks what is an area in OSPF, so you will simply tell area is a logical group of devices. One area is a logical group of devices within a single administration. So basically one area is a group of some devices, and Cisco also specifies, or Cisco recommends, that we should not have more than 50 routers in a single area. Cisco recommends that we should not have more than 50 routers in a single area. And remember that these areas are 32-bit long areas, or area IDs. If you talk about the area ID will always be 32 bits long ID. Area ID will always be 32 bits long ID. And area ID can be represented in the format of decimal number, or you can also represent your area ID in the format of IPv4 address. You can also represent your area ID in the format of IPv4 address as well. Like, it's not always to say that okay, area 0. You can say 0.0.0.0. It will also specify that okay, you are using area 0. I get my point? Because IPv4 addresses are also 32 bits long addresses. And if you talk about the decimal range of area IDs, is from 0 to 4.2 billions. I don't remember the exact value, but it is kind of 4.2 billions, because 2 raised to the power 32, you can calculate it by yourself. 4.2 or 4.3 billion, something like that. It's not million, it's billion. Fine. And remember, if you talk about the areas in OSPF, area 0 will always known as backbone. And also you can call it transit area. All other areas except area 0 would be known as, all other areas will be known as regular area. Understood? Now remember, that by default routes cannot move from one regular area to another regular area if they are not directly connected with backbone area. So it is really mandatory that if you are having two different regular areas, let's say this is R1, R2, R3. This is what area 1 and this is what area 2. So now you are having two different regular areas, and by default routes, updates cannot move from one regular area to another regular area. And if you want that, these two regular areas must communicate with each other, then in between these two run area 0. So now you can see that area 1 and area 2, both of them are connected with backbone area 0. And that is why we call this area 0 as a transit area, because if you want communication in between two different regular areas, then you have to connect them to the backbone area. So that backbone area will become now transit area for those two regular areas. Are you getting my point or not? So backbone area will always be known as transit area, and only area 0 have that capability. You can also ask me that why don't we have this capability in any other area? We have it, but for that purpose you have to configure virtual link. If you configure virtual link over any regular area, in that case you will call that non-backbone transit area. Non-backbone transit area. But after configuring virtual link only. If you have not configured any virtual link over any regular area, then you will simply call it as a stub area. You will never call it as transit area. And also you will not call it stub area. Don't call it stub area, because stub area is quite different. But it will not be a transit area, right? It will be known as a standard area, you can say. Understood? So it is really mandatory to interconnect all regular areas with backbone area. Fine. And along with this statement, I will also add another statement. External prefixes can move from one regular area to another regular area even without having backbone area. But only external prefixes. Only redistributed routes can move from one regular area to another regular area even without having backbone area. But internal routes cannot move from one regular area to another regular area if they are not connected with backbone area. Have you understood it or not? I will also tell you that why these external prefixes can move from one regular area to another regular area even without having backbone area. I will teach you, don't worry about that. Fine?
Why it's necessary to connect regular area to backbone area?
Because by default updates cannot move from one regular area to another regular area. Now you will say that what is the advantage of running multiple regular areas? Run only and only one regular areas. One regular area or one backbone area. Run only common area. If you are having a large network, huge network, as I said that Cisco do not recommend you to add more than 50 routers in a single area. And if you are having like not 50, actually I will say that maximum in live networks we have, generally we do have 10 to 15 routers within a single area. If we are having more than that routers, then generally we will divide them into multiple areas. I'll let you know that what is the reason behind it. See, the thing is, like if you have implemented only and only one area in your network, it will be known as single area OSPF. And if you are talking about single area OSPF, it means it will be a fully linked state routing protocol now.
Yeah.
It will be a fully linked state routing protocol, means that within a single area all routers will maintain a complete topological database.
Yeah.
And now there is a rule that if there is any change on any router in any area, that in that area all routers will get that information and all of them have to run SPF algorithm. And during running SPF algorithm, the CPU utilization will be higher. So if you are having 50 routers, of course, frequently there will be some changes, like sometimes changes will occur on R1, sometimes change will occur on R2 or R3, or every time they will keep on to give updates. They will give every time you will be keep on to make some changes in your network, right? So every time routers will keep on to give an update to each other. So whenever they will receive an update from that router which is also participating within same area, then routers have to run SPF algorithm, and SPF algorithm will consume higher CPU utilization. It will consume more CPU. It will utilize more CPU. That's the problem. So now you decided that, okay, let's do one thing, let's break it multiple areas, so that it will be easy for you to understand it, as well as CPU utilization will be low now. Is not it? So if you do not have the backbone area, the concept of backbone area, and if you have broken your areas into multiple areas now, like area 1, area 2, area 3. So now, according to the rule of regular areas, prefixes cannot move from one area to another area. And if you want to inject prefixes from one area to another area, for that purpose you must have an ABR. And to become an ABR, it is mandatory to have at least one interface in area 0. That is why we are required to have backbone area. Because if you do not have an area 0 in your network, it means you will never have an ABR. And if you do not have an ABR, it means routes prefixes cannot be injected from one area to another area. Only ABR will be responsible to inject routes coming from one area into another area. And to configure an ABR, or to have an ABR, it is mandatory to have an area 0. Understood or not? For sure. Fine. After it, let's talk about types of routers as well. There are some terminologies like backbone router, internal router. Apart from it, you are also having ABR, which is area border router, and also you are having ASBR, which is autonomous system border router. Fine. So what do you mean by backbone router? I mean, if we explain the meaning of backbone router, is something like a router which is having all interfaces in area 0 only. If you are having a router in OSPF who have its all interfaces in area 0, it means you will call it as a backbone router. But there is a condition: all interfaces must be in area 0 only. Internal router: if a router is having its all interfaces in regular area only. If your router is having its all interfaces in regular area only, doesn't matter. Well, might be possible that, let's say, this is R1, this is R2, and this is R3. You understand? And here you are running area 1, and here you are running area 2. So R2 will become not ABR. It will also be known as internal router, because it is also having all interfaces in regular areas only. So I said that if your router is having its all interfaces in regular areas, then also it will be internal router. Next is what? ABR, area border router. To become an ABR, it is mandatory to have at least one interface in backbone area and also one interface in regular area. To become an ABR, it is mandatory to have at least one interface in backbone area as well as in regular area. Then only your router can become ABR. Otherwise, it will never be known as ABR. Next is ASBR, autonomous system border router. In OSPF, all those routers where you have performed redistribution will be known as
ASBR.
So it's all about the redistribution. Let's say that you have performed redistribution on any router, then it will be known as ASBR in OSPF. But redistribution is mandatory. Doesn't matter that what are you redistributing, because you can redistribute your directly connected prefixes, you can redistribute RIP, ESRP or BCP, whatever it is. But the thing is that on any router, if you have performed redistribution, then it will be known as an ASBR, autonomous system boundary router. Understood? Good. After it, let's talk about LSA. First of all, you have to understand the LSA only. That what is the meaning by LSA in OSPF? LSA is what? Link state advertisement. Link state advertisement. So what is the meaning by LSA exactly? Like, I will explain this LSA in this manner only. Like, whenever updates will go from one device to another device, they will always go in the form of LSA. The very first definition. Second, a router will always keep your route's information in its database in the form of LSA only. So LSA is kind of message which contain your prefix information. Not only prefix information, sometimes it will also keep some other information too. Because for different purposes, we are having different LSAs. So by its name, as it looks like link state advertisement, so basically it will be advertising the state of your link. That's why its name is what? Link state advertisement, LSA. And remember that LSAs will always go in the form of LSU only, from one device to another device. If you are talking about the LSU, link state update, so basically LSU contains only LSA. LSU contains only and only LSAs. Full LSA. Not only header, because headers were also contained by DVD2. But this time in LSU, you will be having complete LSA. So remember that in OSPF, whenever updates will go from one device to another device, then they will always go in the form of LSA, which is also known as link state advertisement. Now, let's talk about types of, because for different conditions, we are having different types of LSAs. So types of LSAs, we are having like type 1, which is also known as router LSA. Then we are also having type 2, which is known as type 3 is also there, which is also known as and SSA, LSA. And SSA is stand for not so stubby area. However, we are also having type 6 LSA2 here, which is known as group membership LSA. But it is not in use nowadays, so we are not going to discuss anything about that LSA, which is group membership LSA.
These numbers go until 11, right?
What?
LSA type 11 will come.
Yep, type 8 to type 11, which are known as opaque LSA, which will be used by OSPF during traffic engineering only, not before that. Let me tell you, we are also having type 8, type 9, type 10, type 11 as well, which are also known as opaque LSAs. And these opaque LSAs will be used by OSPF during traffic engineering only. So here we are not going to perform traffic engineering because traffic engineering is part of service provider only. So that's why I'm not going to discuss about all those LSAs here. So I'll be discussing about all these types of LSAs. So let's start it from router LSA only, which is known as type 1 LSA. Router LSA. So if we talk about this router LSA, so you must understand that what is the meaning by router LSA and how, where will we use this router LSA and all these things. Right? So if someone asks you that what is type 1 LSA, or someone asks you like router LSA, so it's same thing, right? Fine. Remember that in OSPF it is mandatory for all routers to generate router LSA. It is mandatory, it is compulsory for all routers. But remember, see, I'm again repeating my words. Router LSA will be generated by all routers in OSPF, and it is mandatory for all of them. Let's say there is a router 1. It is not connected with any other router. What will happen? Let's say here you are having 3 interfaces like Ethernet 0, Ethernet 1, and you are also having Ethernet 2. So if you are having 3 Ethernet interfaces, and if you have configured only one process and one area on this router, so remember that for one process, because here you will also use process IDs, right? So if you are running a single process ID on a single router, and if you are running only single area on a single router, on this router, it will generate only one router LSA for all the links. Does not matter that how many links are available on this router, but it will generate only one router LSA, and in that single router LSA it will inject all links information. Means that one router LSA can have multiple networks information, multiple links information. Are you getting my point? One router LSA can keep multiple links information. So once you will enable this OSPF on this router 1, it will generate router LSA immediately and will install this router LSA in its own database table now. Right? So remember that all routers have to generate router LSA, or all routers will generate their router LSA. If they are running only one area, one process, they will generate only one router LSA, and if you are running one process, multiple area, like 2 areas, so this time R1 will generate 2 router LSAs for 2 different areas. If you are running 3 areas on a single router, then your router will generate 3 router LSAs for each area separately. If you are running multiple processes, like process 1, process 2, and if you have advertised some prefixes into process 1, and if you have advertised some other prefixes in process 2, then also it will generate 2 different router LSAs. Might be that you are running same area IDs in both processes, doesn't matter. Might be that you are running, let's say that here I have put these 2 interfaces in process 10 and I have put this interface in process 20, but area is same, but still R1 will generate now 2 router LSAs. One is for process 10, one is for process 20. But remember that if you are running only one process, one area on one router, then it will generate only one router LSA, and all links information will be carried within a single router LSA. Now there are some other limitations too in router LSA. Like router LSA cannot cross its area boundary. Router LSA cannot cross its area boundary. Like router LSA cannot move from, cannot go out from its own area. Let's say that router LSA was generated in area 1. Now router LSA cannot move out from area 1. Yes, that router LSA will be present on all those routers which are participating in that same area, but will never be present on that router who are in different areas. So router LSAs cannot cross their area boundary. Understood? So because I said that router LSAs cannot cross their area boundary, so how is it gonna to be possible to transmit your prefix information from one area to another area? So for that purpose we will require to have ABR, and ABR will be responsible to break your router LSAs into summary LSA. So I will be discussing it with you, but first of all let's discuss this router LSA only. Are you getting my point? And along with explanation, okay, before going to start its practicals of LSAs, let me tell you one more thing here, that like we were having 24 bytes standard information for all types of packets in OSPF. In same manner, for all types of LSAs, we are also having a common 20 bytes long information. 20 bytes long information for all LSAs. Means first 20 bytes will always remain same in all types of LSAs. Let me show you now. The LSA header. This is known as LSA header. So all LSAs will always be encapsulated by 20 bytes long common LSA header. You see, all LSAs begin with a common 20 bytes header. This header contains enough information to uniquely identify the LSA. Multiple instances of LSA may exist in the routing domain at the same time. If it is then necessary to determine which instance is more recent. This is accomplished by examining the LS, a sequence number, and LS checksum field that are also contained in LSA. What I taught you, that how will you identify that which LSA is the most recent LSA? To identify that, here you see how many credentials are there: sequence number, edge, checksum. That's what I taught you. Is not it? So in first 20 bytes you are having all these fields inside the LSA. LS edge, LS type will be defined like type 1, type 2, type 3. Like if it is router LSA, then it will define 1. If it is network LSA, it will define 2. If it is summary LSA, it will define 3. If it is ASBR summary LSA, then it will define 4. If it is external LSA, then it will define 5. If it is NSSA LSA, then it will define 7. So this whole information, I mean this common 20 bytes long information will be added onto all types of LSAs. Link state ID, I'll be telling you that what is the meaning by this link state ID later on, right? Advertising router will be router ID of that router who have generated that LSA. Sometimes link state ID will also be router ID of that router who have originated your LSA, but sometimes it will also specify your network ID too, your prefix information. So I'll let you know that, okay, in which condition or in which LSA link state ID will define your network ID, in which condition link state ID will define your router ID of the originator, or in which LSA, right? So I'll be discussing it with you later on, but here you can see sequence number is also there, checksum and length. So all these fields are available in first 20 bytes long header.
checksum करता क्या है?
It's for security only. Like what is the role of checksum inside the IP header? I explained you earlier on. Do you remember that I taught you checksum field inside the IP header itself? Checksum was available inside the TCP header, inside UDP header, as well as it was also available in IP header 2. It was also available in Ethernet 2 as FCS. So checksum is kind of like hash value, and is used to perform error detection. Is used to, this checksum field is used to identify that whether have anyone performed alteration in this data or not. If someone have performed alteration in your data, remember your checksum will never match, and there will be some changes in your checksum field. Understood? I get your point or not? So these are the things which are, this is the meaning by checksum, you can say. But remember that it will always be used for security reasons only. Even you can see here checksum. The Fletcher checksum of the complete contents of the LSA, including the LSA header but excluding the LS edge field. That's it. It's a checksum, and this checksum will further used by devices to confirm whether it's this packet is alter free packet or someone have altered it. So for data integrity, for checking of data integrity, you will be using this checksum. Now I hope that you have understood the meaning by first 20 bytes or meaning by LSA header. Remember, these 20 bytes will be common for all types of LSAs. Now, if you talk about the router LSA itself, you see, this is your router LSA. First 20 bytes are going to be same up to here, up to length. Then after, we are having fields of router LSA itself. It means that these fields, these one, will not be available in any other type of LSA, because only first 20 bytes will be common, and all other fields, all other bytes, all other fields will be different as per LSAs, type of LSA. So in router LSA, as you can see, first 20 bytes are still common, and then after you are having some flags here like VEB. V says that it is the endpoint of virtual link. Endpoint of virtual link. E says it is ASBR. B says that it is an ABR. Now let me tell you. Let's say there is R1, there is R2, there is R3. I got your point? Here you are running area 0 in between R1 and R2, and between R2 and R3 you are running area 1. So now R1 knows very well that R2 is working as an ABR, because if you configure commands to IP OSPF border router, R1 will show you that R2 is working as an ABR. So how it came to know that okay, R2 is working as an ABR? How is it possible for R1 to come to know about this information?
With the help of router LSA.
With the help of router LSA. What happens actually, that whenever R2 will generate its own router LSA for area 0, because this time R2 will generate two different router LSAs. One is for area 0, one is for area 1. So in both router LSA, whether it is generated it for area 0 or it generated it for area 1, in both router LSAs it will enable B bit, B. So whenever R1 will receive this router LSA coming from R2, it will receive that router LSA with B bit. It means R2 is working as an
ABR.
simple, very simple. Are you getting my point or not?
Yes, sir.
So this is the uses of B bit. Now let's say that on R1 you perform some redistribution. Here you are having ESCR pin between this router and R1. On R1 you perform redistribution, it have become now ASBR. Now if you configure this command on R2 that show IP OSPF border router, it will show you that R1 is working as an ASBR. So how will it be possible for R2 to come to know about this information that okay, it is working as an ASBR? So what happens that when a router becomes an ASBR, it will regenerate its own router LSA with E bit. E bit will be on in that case. So that whenever this R2 will receive this router LSA inside area 0 coming from R1, it will find E bit. And if it found E bit, it means that it is working as an ASBR. Have you understood it or not?
Yes, sir.
Fine. And VBIT is also really important for us to define that. Okay, I mean, how will we tell to routers okay, that this is your endpoint of virtual link? This is the endpoint of virtual link. So wherever you will configure this command area 1 virtual link is this. That router in its own router LSA will specify this VBIT as 1. It means I am the endpoint of virtual link. On another end also you will configure this, okay, this command, that area 1 virtual link with this. That router will also originate its own router LSA with VBIT, so that now routers will come to know that, okay, these two are the endpoints of virtual links, and then after they will form virtual link neighborship, and the remaining things I will discuss it with you. I will be discussing with you during virtual link explanation only. During the practical of virtual link, I will show you that, okay, this is the VBIT and this is the uses of it. What? There will be VBIT enabled in two different router LSAs. There will not be two VBIT. There will be VBIT enabled in two different router LSAs. Because whenever you will configure virtual link, you will always configure that command onto two different routers. So wherever you will configure that command, like area 1 virtual link, it will originate its own route. It will re-originate its own router LSA with VBIT. So if there is any change inside their bits, like now if your router have originated router LSA with VBIT or EBIT or with the BBIT, in that case it will never increase its sequence number. It will simply recalculate its checksum and will transmit that LSA, that update with same sequence number. So how will it be possible for neighbor device to receive, to accept that LSA, that information now, that update now? Because it is coming with same sequence number, so it will compare its checksum value now. You understand? And then after, you are also having some other information here, like link ID. This is all about the LSA, entire LSA. Hello, LSA. I mean, this is router LSA actually, but in it you are having like link ID, link data, link ID, link data. I mean, inside single router LSA you can have multiple links information. Like this is link ID, link data. This is one links information, right? Up to here. Up to here, this is one links information, and then further, this can also contain another links information. Then further, it can also contain another links information. That's why I said that within a single router LSA, you can have multiple links information, multiple networks information. Fine. So now, in case if you are having this kind of diagram. R2, R3, R4, R5, R6. This type of diagram. So let's say that you have enabled common area on all these 6 routers. So how many router LSAs will be there? 6. 6 router LSAs will be there now. And all routers will be having those all 6 router LSAs now. It means all of them are having a complete topological database. It means that they can define their best path election. They can elect their best route. They can calculate their best path by themselves. They will not be depending on that information which is given by their neighbors. And actually here routers will not exchange only those routes only which are available inside their routing table. They will exchange their database only. They will exchange their database. That is why here we do not have any concept of a split horizon, because here they are not exchanging their routes information, whereas in ESGRP and RIP they were giving only routes information, prefixes information. Have you understood it? Now, if you are implementing only single area on all these 6 routers, and if you make changes on any one of the router, like you made some changes on R1 will regenerate its router LSA now and will advertise it towards all others. Do you understand? So whenever a router will receive an updated router LSA, it will accept it, will install its own database table and will schedule SPF and will run that SPF algorithm and will again install best routes inside its routing table. But this time you see all routers, all 6 routers have to run SPF algorithm. That's why I said that you must not have more and more routers in a single area, because if you are having like a huge number of routers within a single area, then of course changes will occur frequently, and if changes are occurring frequently, it means that all routers in that area, all those routers have to run SPF algorithm frequently. And now you can easily imagine that what can happen to your devices if it is happening in your network. That is why it is always recommended to break your network into multiple areas, into small areas. However, if you talk about the traffic engineering can be performed within an area. That is why in enterprise network you will always find single area OSPF. And one more thing, it is a linked state routing protocol, fully linked state, but within a single area. If you are implementing multi-area OSPF, then it will also contain some features of distance vector routing protocol too. That is why in live networks we do not prefer to configure OSPF yet. We prefer to configure only and only ISIS. In the background of BGP, at the end of ISPs, you will always find ISIS only. Because ISIS is the only protocol which is completely fully linked state routing protocol. And these two protocols, ISIS as well as OSPF, also supports traffic engineering. So it doesn't matter whether you configure ISIS or OSPF. MPLS traffic engineering is supported by both of them. However, it is not supported by either EICRP or RIP. That is why in the background of BGP at the end of ISP, you will never find EICRP or RIP. You will always find only and only, either ISIS or OSPF. Understood?
Yes.
Okay, so that's the end of today's video. So I hope you learned something new today. We'll be coming with few more videos of OSPF, guys. See you later. Thank you.